Okay, so in this video, we will consider three additional examples of a U-substitution. So here's the first. So sine of root of x over root of x dx. Now if you look here, it might not be obvious, as we are dividing by root of x, and clearly the derivative of root of x will not be sine of root of x. So it doesn't look like we have an obvious choice of a function whose derivative is multiplying the expression. But if you do a simple tweak here, and you don't think of dividing by root of x, but if you think of it as sine of root of x, and dividing by root of x, of course, is multiplying by 1 over root of x. Now the u sub should be more apparent, as the derivative of root of x is 1 over 2 root of x. So up to the factor of 1/2, the derivative of root of x is indeed multiplying the expression. So this is a perfect setup for a u sub. So we let u be root of x. As we have just said, use a function of x, differentiate u with respect to x. You can think of root of x as a 1/2 power. Using the power rule and bringing back to a root of x will give you 1 over 2 root of x. Well, you can multiply by dx, and you're going to have that du is 1 over 2 root of x dx. But we don't have 1 over 2 root of x dx, but we only have 1 over root of x dx. So multiply both sides by 2, and you'll get that 2 du is 1 over root of x dx. And now we're good to go. So sine of root of x, but root of x is just u. So all of this becomes sine of u. And 1 over root of x dx is just 2 times du. And now the integral is basically trivial. Factor the 2 outside, as it is a constant multiple. And we are looking for a function whose derivative is sine. Well, the derivative of cos is negative sine. Therefore, the derivative of negative cos is positive sine. And we want the final answer back in terms of x. And u was just root of x. So we replace. And we get negative 2 cosine of not u but root of x plus c. And we're done. So you have to be careful sometimes that you don't miss a division for really a multiplication by 1 over the expression. Let's look at one other example, very similar. Now instead of a root of x, just a ln of x. So what if we ask to integrate cosine of ln of x divided by x? Well, same thing here, right? The derivative of ln is 1 over x, and because we are dividing here the expression by x, we really are multiplying it by 1 over x. So we have a perfect setup again for a u substitution. Here's a function, ln of x, whose derivative, 1 over x, multiplies the expression. And so we let ln of x be u. Or u be ln of x, same thing. To find the dx, we must differentiate. So u is a function of x, so we can differentiate u with respect to x. The derivative of ln of x is 1 over x. Multiply by dx, and du is quite simply 1 over x times dx. And now we're good to go. Cosine of ln of x. Replacing ln of x by u gives us cosine of u. This takes care of this expression. And 1 over x dx is just du. Once again, this is a rather simple integral. We are looking for a function whose derivative is cos of u. Of course, it is simply sine of u. Going back in terms of x, u was ln of x. So our final answer is the sine of ln of x plus c. So there you have it. So keep in mind that sometimes a division is really a multiplication by 1 over the expression. So you don't miss these rather simple U substitutions. And that's it.